So at the moment, wind is actually generating around 15% of the UK's electricity. Obviously, it doesn't do that all the time, and it is a variable source of power. So sometimes it's less, sometimes it's more. But I think what's really important is how much is generated over the course of a whole year. And last year, wind in total produced about 10% of the UK's electricity.
And it's not quite correct to say the wind is unreliable. We can, of course, forecast wind 24 hours even further out as our technology develops as well. So that can help us ramp our power stations up or ramp our power stations down, depending on the wind speed of the day.
Indeed, and as we get more technology develops, so there's more interconnections as well, and there's better batteries, then perhaps we'll be able to store a lot more of the power that is generated, and then we can shift it to be used when the demand is there and needs it.
It's too simplistic an argument to say that it's a one-for-one ratio, that you have to have as much backup reserve capacity as you do wind. Interconnectors, energy storage systems, and indeed demand-side management all help you to control the energy flow and will help to reduce the amount of backup installation you need to cater for the wind when the wind isn't blowing. There's also the demand-side management side of things, and that's become more and more a feature of our electricity grid, the ability to reduce demand at times when maybe energy is less available because the wind is lower. So again, there are many compensating mechanisms that are coming along now that will help the deployment of wind in the future and enable us to achieve even more wind contribution from wind than would otherwise be the case.
And interconnector cables to countries like Nordic countries who have an oversupply of hydro will help us balance our wind supply and also balance price spikes for consumers as well. And it's potentially an opportunity for the UK to export our wind resource and make the most of it even more for the UK economy than we are already.
And I think as well, the UK already has a lot of flexible thermal generation like gas and coal that it can use at the moment. So our electricity system at the moment is very, very well placed to be able to absorb a lot of capacity from wind turbines.
Mm-hmm. I think there's a bit of a misunderstanding here. I'm not aware of any wind turbine anywhere in the world that has auxiliary diesel power to provide that service. I think most modern turbines now, when they are idle, and by that I mean not generating, then they're left with a brake off, so they do have the ability, or the rotors can turn around slowly to avoid any problems associated with equipment standing stationary for too long. There's also the ability to run the power the opposite way through the turbine and motor through the generator a little bit to prevent the sort of issues that the question alludes to. But this is not anything unique to the wind industry. All large power generation turbines have what's called in the steam turbine industry a barring requirement to prevent them standing stationary for too long and suffering damage.
I think it's just a misunderstanding about what technology is involved in a wind turbine. There are not diesel engines sitting inside wind turbines.
Tidal technology is, of course, still as yet unproven. There's been a lot of talk about tidal technology, but we still haven't yet built the first lagoon in the UK or in the world. Offshore wind is a technology that we have here, and we have here today. Costs are falling and will continue to fall as we develop more and more projects.
Indeed, I think whilst you can predict tidal outputs years and years in advance, it won't necessarily correlate with exactly when the demand is going to be. We've already seen that offshore wind is incredibly predictable, about 24 hours ahead of real time. So, yeah, offshore wind is here, it's ready to be deployed, and the costs are coming down, and it's certainly a lot cheaper than tidal technology.
And onshore wind is working. We have more offshore wind deployed than any other country anywhere in the world, and that's a big thing for the UK, and we should be proud of that. There's an element of the generation from wind following demand. Winter times when power usage is at a maximum tend to be more windy. Can't be guaranteed though. There are, if you look at the Met data from this year, there are periods in January when there was low wind, but by and large, if you aggregate across the year, there is some matching of availability of energy from wind to demand.
Indeed, and by having a balanced mix, we can meet those different demands from all of our sources of energy rather than relying on one or two.
Yeah, there are all kinds of exciting opportunities around renewable energy to optimise and get more out of our current systems as well. So there's lots of studies in recent years looking at dynamic cable rating, for example, because when the wind's blowing, the power lines, the overhead transmission lines, are cooled more than they are in low wind times, so you can actually push more power down the existing assets when it's windy. So if you put your turbines at the end of those, there's actually, if you really look at that sort of level, there's additional optimisation without building any new asset at all to be had.
But I think there's going to be a big change in how we use electricity. Obviously, the electricity supply is going to get a lot more decarbonised as we get towards 2020, 2030. But also over that period, there's going to be other sectors, predominantly transport and heating, which is also going to change. They're going to become a lot more dependent upon electricity, so we'll have electric cars and that sort of thing. And that will actually help even up the variability of wind, so we can charge our cars at night when there'll be a lot of wind power, which will mean the electricity price will be low. So people can take advantage of that as well. And I think as we get more technologies on the grid which have very low marginal costs, so the additional cost of generating a unit from a wind farm is zero, we will get much more variability in wholesale power prices anyway. So there'll be a lot more scope for consumers to tap into that with their smart app on their phone and really be able to time their electricity demand to the periods in which the prices are really, really low.
Exactly. It's about giving the consumer choice, and offshore wind can be a big part of that.
You certainly can. 24 hours ahead of real time, you know pretty much exactly how much output an offshore wind farm will be generating. Okay, the output is variable over the long term, but generally the load factor, which is the proportion of the potential output that's generated in any one year, is very, very high.
And in fact, there's a misperception that wind turbines only work for a small part of the time. The three best offshore wind farms last year, 2014, worked all year 50% of the time. They were at the equivalent of full output. And that's a really useful contribution to the power system.